Question 8 gives us a piecewise function, and what we notice is that the function is being split, right? This piecewise is being split at -2, -1, and then 2. Note how here these aren't connected, right? So we're not going from -2 and then starting back at -2 here. There's actually this gap, this jump from -2 to -1, okay? So this leads us into kind of part A, which is asking us what's the y value? What is the function f when x is -3/2, or really t, right? T is the variable in question here. So when is t equal to -3/2? Well, I don't have a function value when t is -3/2. Like we just talked about, the function is only defined for things less than -2, and then between -1 and +2, and then greater than 2. So -3/2, which is about -1.5 in a decimal version, it doesn't exist, right? There's no region here. There's no expression that corresponds to that in my piecewise function. So technically, A would be does not exist. Okay, there's no y value that satisfies that, right? B is asking us f of 2, right? So when t equals 2, what's my function output? That one you can solve though, right? Because looking at the graph at +2, I don't want this one, right? Because this is less than 2. It's not actually equal to 2. When t is equal to 2, I could use the bottom expression. And so then the function at 2 becomes 3 times 2, t plugged in for 2, minus 2. That's 6 minus 2, which is 4. Okay, so you can see we're starting to find some y values here. Y value at -3/2 didn't exist. Y value at 2 was 4. What about the y value at 3/2, or +1.5? Well, again, that would kind of fit into this guy here, right? Our middle expression, because 1.5 lies between -1 and 2. And so we'd plug that in. We'd get 3/2 plus 6 over 3/2 squared minus 3/2. Now, as you can see here, this is a complex fraction, right? There's a little bit of a mess. So what you could do is kind of use some techniques that we've seen in the past. So I have this, and then a denominator. Remember, this would be 3 squared, 9. 2 squared would be over 4 minus 3/2. And what I can do is I can multiply all of these by the denominator that I want to cancel, right? So I notice like I want to get rid of the 2, but I also have a 4. So if I multiply everything by 4, that would get rid of the 2 as well, right? Because 4 divided by 2 would just scale up by 2, but I could simultaneously cancel out the 4s. So I'm kind of trying to use this to my advantage, and I'm multiplying by 4. This term times 4, right? So all of this is being multiplied, right? So this by 4 would be 3/2 4, which would be 4 and 2 simplified to 2. 3 times 2 would be 6. 6 times 4 would be 24. And the denominator, 9/4 times 4, the 4s would go away, right? Bottom and top. I get 9. And then -3/2 times 4. Remember, the 4 over 2 would produce a 2. -3 times 2 would be -6. So I just work on that. So 24 and 6 would be 30. 9 minus 6 would be 3. 30 over 3, we get 10. Awesome. Okay, so we're just finding y values here. Yeah. Now, we move into finding the limits. So here, let's start with D, limit as t approaches -2 of f of t. So as we go towards -2, note that there is only a left side of -2. There is no right side of -2, right? Because remember, we talked about the jump. So we only are on the left side of -2 here. So this means that this limit does not exist because this is a two-sided, and I could say as the limit as x approaches -2 from the right side of my function does not exist. Okay, so now we're going to take a look at E, F, and G. Now note, I just put a copy of our piecewise function down here, so it would be easier for us to take a look and we don't have to scroll up and down. So at E, we're looking at the limit as t approaches -1 from the right side of f of t. Now from the right side of -1, we're going to be at this middle expression, right? So we're coming from numbers that are slightly bit more positive than -1, which would lie in that range. So I would go ahead and basically just take the limit as t approaches -1 from the right side of this expression. And when I plug in -1, we should be good to go, right? -1 plus 6. Remember, if you want to keep the notation from the right side, you can. But since I'm plugging in -1, none of these look like they're going to really cause me issues at -1. So I'm not really worried about a plus or minus in direction, right? It's not going to change anything. So -1 plus 6, it's going to be 5. Whether you think 5 from the left or 5 from the right, it's 5, right? We're taking a limit, it's going to 5. Same thing on the bottom. You get -1 squared minus -1. -1 squared is +1. Minus minus would also be a +1, right? Two negatives turn to a positive. This becomes 5/2. Okay? So limit from the right side there is 5/2. We tackle f now. What happens when I go towards 0? Well, 0 is going to be this middle expression, right? So 0 is between -1 and 2 for t values. So I'm going to use this. But since it's a two-sided limit, and it looks like when I plug in 0, the denominator goes to 0, I'm worried about the left versus the right side, correct? So what I mean by this is when I plug in limit as we go to 0 of t plus 6 over t squared minus t, I'm noticing I'm getting 6/0, which leaves me the question, is it positive or negative infinity, right? And so I have to kind of look at the denominator and see really what happens on that. So let's look at the left side. So let's take as I go t towards 0 from the left. Same expression, right? Nothing kind of changes. I'm still using the t plus 6 over t squared minus t. But I have to think about what happens as I go from the left side. So if it helps you, what we could do is we could factor the denominator. So you see how there's a t in common. So maybe that might give you a little bit more insight here. So if I factor out a t and I get a t minus 1, maybe this will make more sense logically here. So let's plug in 0. The top would still be 6, right? Even plug in 0, like we talked about, same with the 5 up top, right? If it's going to 6, it's going to 6. It doesn't really matter left or right side. On the bottom, though, you'd get 0 from the left for this first t. But then on the second t, you basically are getting multiplied by -1, right? Again, this 0 versus the 1 doesn't change anything. -1 is -1, right? Whether it's from the left or right side, you're going to -1. So what happens here? Well, it looks like the numerator is positive. The denominator, 0 from the left, would be a slightly negative number times another negative number. Two negatives multiplied would be a positive. This is going to push me to positive infinity. Okay? It's going to push me to positive infinity. Now, if I apply the same logic as I go to 0 from the right side, we'll keep that denominator factored there. It seems to have helped us in this scenario. So I get positive 6 over 0 from the right side times -1. Well, clearly, positive times a negative would be negative, so the whole ratio is going to be negative. We get negative infinity. Therefore, these are not the same, right? From the left and from the right, we're not getting the same value. Therefore, the limit as t approaches 0 of my function f of t does not exist, right? Does not exist. And then we can say as, and then just show that those are not equal. Okay? So hopefully that makes sense, right? Same as what we've been always talking about. We're focused on two-sided limits. Got to verify that those are really two-sided limits. Last but not least, we take a look at g. We're going as t approaches 2. Now, as we approach 2, note here that both of these matter, right? This top expression, or in the whole thing, the middle expression would be from the left of 2. The bottom expression there would be from the right of 2. So this, when you take the two-sided limit, you got to look at both, right? So I'd have to take limit as I go 2 from the left. 2 from the left would be, like I said, the middle expression. And if I were to go to, if I were going to 2 from the right, I would get the 3t minus 2. Okay, so I'm taking the limit of this guy, and I'm taking the limit of this guy on both sides. We're going to see what happens here. Start with the bottom one. I'm already here. 3 times 2 would be 6. 6 minus 2 would be 4. If I plug in the top, 2 plus 6 would be 8 over 2 squared, 4. 4 minus 2 would be 2. 8 over 2 is also 4. So look at that. I get 4 on both sides. Therefore, the limit as t approaches 2 of my function f of t would also be 4, right? We get the two-sided limit. Both sides were 4, so our two-sided limit is 4. Awesome. Okay. So this is how we were working with our piecewise functions, not only finding y values like we did in the beginning, but also finding limits with a big emphasis on two-sided limits, right? Checking the left, checking the right, making sure that these are the same on this piecewise function. Okay. Awesome. It's question 8. Let's keep going.